we are very excited to showcase the best paper 2024 in International Journal of Fluid Power. The paper that won is Energy Efficient and Redundant Steer-by-Wire for Articulated Non-Road Mobile Machines by Vinay Singh, Mikko, Huova, and Tatiana Minav from University of Tampere, Finland. I'm here with the authors of the paper as well as the journal's editor-in-chief, Professor Andrea Vacca. So big congratulations to the authors, and I will let Professor Vacca introduce himself and the journal.
Thank you, Hannah. So welcome everyone, and my name is Andrea Vacca. I'm professor at Purdue University, and I'm also the editor-in-chief for the journal. So just to give a few words about the journal is the reference journal for the Global Fluid Power Society, and is the only journal that focuses 100% on fluid power and actuation topics. So everything that uses pressurized fluid to perform an actuation and related components and control are part of the topic of the journal. So the journal is under River Publisher. Over the last years, we were able also to have a great achievement with the journal because we have raised in the past year the citations by 50%, going open access. That was a great move. We were able to get faster review and still ensure that we are strict. Our rejection rate is 50% last year, fluctuates between 40-50. So it's a quite selective journal. We gained impact factor about 1.5 years ago. We also raised the ranking in the Q Shimago category. We are Q3, but I believe that we are in a trajectory where hopefully we'll get to Q2 in a couple of years. So I hope that this will really happen. We started a couple of years back with the initiative to prize the papers that we believe are top-notch, but well, all the papers are in the journal, of course, are very, very high quality, I personally think, thanks to the work of all the associate editors and the reviewers. But what we look to choose the best paper are additional factors. So we go to the website and see which are the journals that they get most views and downloads. So we keep track of that. And also if there are papers that they get citations, which of course at the end of the year, looking at the papers that they get cited is not an easy thing to consider because it takes time to get the paper cited, but certainly the views and the downloads is a good indicator. So we choose about 10 papers, then we short selected 5, and then I asked to other directors of the GFPS what they think, and this is how we came up with this paper here. So that is about the selection process, and I think it took already too much time because we are here to talk about the paper. So you already mentioned the title, and is a topic I believe that is of high interest, that is how to improve efficiency, and the authors that touch the topic of the steering system. All off-road vehicles, they almost all they use fluid power system to perform the steering, and the steering is not just about how to the steering, how to achieve the functionality and the energy efficiency, but there is also the safety, because it's a critical system that has to satisfy safety requirements. So I believe that the nice thing and the original thing of this paper is that both of the aspects were addressed by the authors. So with that short introduction, I want to leave the floor now to the two of the three authors of the paper, that they can give more the context and some highlights of the papers. So Vinay, if you want to go ahead, please.
So first of all, thank you for the award, Professor Vacca, and to all the scientific committee for this. It's an honor to receive this award. And about the paper and the idea, I would say it began right here in this room with the EMMA steering group meeting. We were having the first kickoff meeting of EMMA project, which was just concluded last year. And in that, there were a lot of OEMs from Finland. And when we were defining the requirements of the project, what applications we should focus, then steering came as one of the top on the agenda. And that's where I started it. And I would say I was not an expert in safety and functional safety part on the steering, but I had a background in hydraulics. But to come up with this application like steering and any solution we have to consider like safety aspects of that also. So that's why I just combined both the aspects, the safety for the steering and then the main motivation overall for any work on this was the energy efficiency of the steering. So that's where the whole idea came from, and it went quite well, I would say.
Yes, I would say, as Vinay highlighted, this came from the industry, as a lot of academic research is concentrated on one topic. And now we wanted to make it much closer to realization and functional safety. Just pop it up. Let's tackle it. And Vinay did it very well in his speech.
Yeah, no, thank you. And please cover for the audience a little more on the strategy that you are using, right? The keyword would be electro-hydraulic or electro-hydrostatic actuator, right? There are different ways people they want to use, and which is a technology that many they consider new, even if it was conceptualized long back. But it's finally the time where OEMs are finally looking for actual use. And can you cover a little more how you use this technology to implement the steering and what are the specific features to implement this technology for that function?
Yeah, so this electro-hydrostatic actuator, as you said, it's an emerging technology, or I would say in off-road machinery, it's at least emerging, and more and more OEMs and more machinery is being equipped with this. But this is an umbrella term, you see, electro-hydrostatic. So what is specific in this paper is actually an electric motor controlled electro-hydrostatic actuator, which you can say. And in this, the main concept is to remove all the auxiliary valves so that we can get rid of the throttling losses. And that is theoretically most energy efficient part. So that was the motivation to choose this technology of electric motor controlled electro-hydrostatic actuator. And of course, like again, the main motivation to do the work was the energy efficiency. We will have to get the better energy efficiency. We will have to get it electrified, but we cannot forget about the safety part. So yeah, that's where this electro-hydrostatic actuator, electric motor controlled EHA came into this, because theoretically it's most energy efficient, and we just produce the power as it is required by the application in this kind of you can see system, EHA system. So that is what is used in this paper.
Yeah, thank you for explaining. So, and in your paper, you also cover how much energy, what is the gain that we can have over a conventional system. Can you elaborate on that?
Yeah, so basically that is the concept of electro-hydrostatic actuator moving more electrified. Let's say in conventional, any heavy machinery, there are this mainly conventionally we control any actuators, be it steering or be it any other actuator using throttling valves. And a lot of energy is being wasted there. So typically we achieve efficiency of sub-20s in these systems. But if we take, we only produce power as is demanded by the application. So we don't need to necessarily waste the rest of the power in throttling. And that is the concept of this electric motor controlled electro-hydrostatic actuator. And that is why we choose this topology here, as we can only generate power using electric motor as we need it. And that's where the main efficiency advantages, as you can see in the paper, comes from.
Yes, basically we are using on demand. When it's needed, it's produced. If it's not, system is shut down, which is the main concept of this kind of decentralized type of systems.
Yeah, and for who is listening, if you read the paper, they also quantify, taking the reference case of a loader, that from 51% energy wasted in the steering, you can go down to, if I'm not mistaken, to 29, right? That is what you have. So it's a great gain, and that is the motivation why now OEMs they're considering that, or should really consider that. I'm curious on the status of this project. So the work that you have published shows that simulation and then in a digital twin environment, so using cutting edge way nowadays that researchers have to prove results. But what are the next steps?
Yeah, so this paper was, as I said, first in the series and actually first of my PhD journey here. And after this, there are at least 4 or 5 more publications on the same concept regarding the different aspects of this, including using, let's say, artificial intelligence and all these things. And for that, I have also made a little prototype for this in Aalborg. I was recently there for 6 months. And with Danfoss Power Solutions, we made a prototype, not exactly the same concept as is shown in the current paper, but a little bit different. And for the exact same kind of prototype, we are already like working or at least in talks with a company I am. And let's hope we can make a prototype of the exact same concept, but like a little bit, you can say, reduced order. It has already been done. And there are other publications, and next is I am completing my PhD thesis on this.
Yes, this work is part of Vinay's thesis, and I do have his thesis on my table. It's in review, and we're expecting defense to be coming soon, maybe 3-4 months. And this work is a core of recently ended project, MA2, and now we're in active communication with our Finnish industry members to start new project, Samantha, which will use this work, to next level, how it could benefit OEMs and our industrial partners.
Very good. I want again to congratulate you for this work and also for the perspective on the project. And we understand that is more to come, and that is always very good to see this type of project where also myself I'm particularly passionate about. So looking forward to that. And I encourage everyone to download the paper, read the paper. Is open access online. Again, the title is Energy Efficiency and Redundant Steer-by-Wire for Articulated No-Road Mobile Machines. So with that, I think we can conclude here.
Okay, so I would like to thank you and the journal once more, and I would like to thank my supervisor and other supervisor who couldn't be here today. So it's really an honor to receive this award, and just thank you, and thank you, Anna, for organizing this.
Yes, we would like to thank on behalf of me for opportunity to talk to our readers, get attention to our research. And also I would like to use the opportunity to invite fluid power community to our Scandinavian International Fluid Power Conference, which will be hosted by Innovative Hydraulic and Automation Laboratory here in Tampere in 2 years. We are going to talk more how to decarbonize off-road machinery, how to enable fluid power to be in the machines in new energy efficient and sustainable way. Thank you very much.
Is the fluid power community that is thanking you for the diligence in doing rigorous work. Very good.
Very good.
Bye, everyone.
Thank you.
Thank you.